Hello, I'm WP Swazo, and I'm here to talk about applying a price index and removing inflation. Here's my name. Look for it if any other videos on other topics are available. Your favorite high school teacher maybe asked you, what is one apple plus one orange? One apple plus one orange, as everyone knows, is a famous trick question. One apple plus one orange is one apple plus one orange. Apples and oranges are different. They cannot be added together. However, we can add together apples and oranges if we add together their prices. But if we add together their prices, if we use prices, we're going to be using inflation. So what we have here is an experiment. I turn to it now. Imagine your grandparents are semi-retired, and during this retirement, they sell apples. If we only have one product, and we count that product's prices and nominal revenues, the problem with the nominal revenues is since we're using prices, they will contain inflation. Nominal figures contain inflation. But if from the nominal figure, if we take out inflation by dividing by the given price index and then multiplying by 100, what we should have for the real or price adjusted figures is something that matches the unit change exactly. It'll fit together like lock and key. Now, taking a look, I want to make sure you hear me. So, we have 1 through 6 years, and your grandparents are selling apples at various prices and at various quantities. Looking at this here, leaving year 1 and going to year 2, your grandparents get $1 more per pound of apples, but they're selling half as many apples. So really, you should think of your grandparents as being half as busy selling half as many apples, but according to nominal figures, they're only 1/4 less busy. And the reason why that is the case is because prices distort real outcomes. The price of apples collapses down to $1 and their sales fall even further. So if you look at this, their nominal figures is only 30. Now we know that 30 is a little less than a third of 100, but according to this, with prices, they're actually selling less than a sixth in dollar sales. So now you're ready to tell your grandparents that you're ready to quit the apple stand and go into full retirement. Then what happens going from year 3 to year 4? Sales, quantity sales stay the same. But if we look at the price of apples, they skyrocket. So we could say to your grandparents, wow, you're much more busy, 2.5 times more busy, when in actuality, your grandparents are selling as many apples. Looking between years 4 and 5, the price for a pound of apples stayed constant, it was the same. Sales more than tripled. So all of the increase in activity for your grandparents in years going from year 4 to 5 can be attributed to actual apple sales, because in this range we have stable prices, but that's hardly ever the case. If you look at the prices here, they're always going up and down. In year 6, they sell more apples than ever before, but the price of apples collapses. Maybe there's a bumper crop, and that doesn't play out in the dollar figures. According to the dollar figures, year 5 was their busiest year, when actually year 6 was their busiest year. So prices contain inflation, and inflation is distortion. Now, here are the price indices here. If 100 is your price index, no adjustment is needed. We just pass the nominal figure through, because we would be dividing by 100 then multiplying by 100, which does nothing. To divide by a same number and to multiply by a same number is the same thing as taking your shoelaces and tying them and untying them. In the end, you've done nothing to them. If these apple prices remain in the middle of the price index, these price indices, or this price index with its index figures, would be perfect to use for this. But that's not your concern in this exercise. We are going to take each of the index value and divide it into the nominal value. So if you look at year 2, your grandparents sold $150 worth of apples, but there was an apple inflation. So the price index was 150. Prices were 50% higher than normal. So what we do is we take this 150 nominal figure divided by 150 and then multiply by 100 to get 150. Now, if you look at this here, we say, all right, going from year 1 to year 2, they sold half as many apples. Going from year 1 to year 2, they sold half as many apples. And that should be reflected here, yes. Because 150 divided by itself is 1, and 1 times 100 is 100. So in year 2, they were half as busy as year 1. In year 2, they were half as busy as year 1. But the nominal result does not show that. The nominal result only says they lost a quarter of their sales. If we keep on looking at some of the other years, from year 2 to 3, price went down, price collapsed, and sales collapsed. So what we're doing here is we're taking these $30 in nominal sales, we're dividing them by 50 and then multiplying it by 100. Since prices were half as much, we're in essence going to double this. So now we have 60, and that is more reflective. So year 3 was just under a third of sales of year 1, and 60 is just under a third of 200. We keep on going to year 4, and year 4, both price, in year 4, only price recovered. Only price recovered. So if only price recovered and sales stayed the same, then our real values ought to reflect that, and they do. And they do. Real sales stayed the same between years 3 and 4. If we keep on looking, going to year 5, prices were stable, but sales more than tripled. 60 to 200, more than tripled. So far, our real results have been holding true. The last year, year 6, was the busiest year for sales. That's not shown by nominal figures, but if we look at real figures, that is true. As a matter of fact, in the last year, twice as many apples were sold than in the first year. And that's what the real figures show, the last year being twice as busy as the first. However, the nominal figures show that those 2 years were the same. So if there's something that could be said about prices, just take a price index and divide it into your nominal, multiply by 100 to get your real adjusted figures. Thank you for watching.